What we're going to be talking about today, and I'm going to get started back over here. We'll kick back off at the beginning. There we go. It's another one of the Foxborough Southeastern IA Users Group meetings, and we are today talking about more HLBL best practices. I am David Johnson with Premier System Integrators, and you can reach me at the email shown, David Johnson, premier-system.com. And today we're going to be doing session 3 of the HLBL best practices, and today we're going to be talking a lot about memory management and some things that you may or may not be aware of, and the way that it allocates memory and ways to save memory, things like that. Once again, just for reference, I've put the documentation in there for the various pieces of software, or the Foxborough documents about the HLBL software, so it helps to be able to go back and reference those. We recap session 2, which we did last time. There's a video up on YouTube from the call, and we discussed good ways of doing variable naming, constants, comments, understanding what the VPC STM does, the base processing cycle statements, how many you can do. So you can go check that YouTube video out if you get a chance. Today we're going to talk a little bit about sequence code memory and what we think we know. Foxborough has a little bit written about it, but it's not very clear what's really going on, at least from the documentation. We're going to talk about call by value versus call by reference, what that means, and when subroutines variables use in or in out, and why you should care about which is using. And then global variables versus local variables when you're using a subroutine, C space and C size, and what we can get out of using those, and then we'll discuss any other questions you might have. This one could be fairly short depending on how much feedback we get. I have done a little bit on it and tested some stuff, but have been pretty busy with other things, so we'll see how it goes. One of the things that we know is the CP memory allocation. According to the documentation, we have a max of 3,200, I assume it's bytes. They kind of just throw that out there, but they tell us that's what our max C space or C size can be. And then we also know that recompiling sequence code that gets beyond the reserve space causes memory fragmentation in the CP. And so now we're going to start kind of taking a look at this, and we'll discuss some ways that we can work around it. So let's start with talking about the difference between call by value and call by reference. And that's going to be important to how much space a piece of sequence code takes up. Okay, so and I've got some code here that we can look at. Okay, and this is our call by reference. And when you do a subroutine, we have some various parameters we can set. So what I've done, I'm going to make this bigger and slow down a minute, and we'll come at it. Okay, so I've defined an array size of 300 elements, and we're going to go through this and be able to look at this as we go. And then I just set a variable so that I could hold it where I wanted to with a pause. And so I made a subroutine called reorder the array. This is just a subroutine, and here you can see we're doing an in-out to call it. That is the default, okay, is an in-out. And what that is a call by reference. And when you call a subroutine and you pass it something by reference, it passes a pointer to that element. It does not copy the values of it, which is a call by value. So all it's doing is it's letting you manipulate the actual item that you're passing it. So in, out, or nothing here, depending on what you put, is going to pass that as a call by reference. And then I've got it looping through the array, and it takes all of the elements It just takes the index and it's going to multiply that times negative 11.11, and then we're going to put these values out on the screen so you see what they are, and then when you get down here to the bottom, we will show that the value, the main array, and we'll go through this and show it before we call the subroutine and after we call the subroutine. So that's the intent of what we're going to do. So let's look at call by reference first. This is the default if you call one of these. Okay, so here we've got our block ready to go. And we'll turn it on. Okay, and when I give this a non-zero value, which I did just to hold it, you're going to see that it comes in here, and we've shown that array elements 1, 2, and 3 have 1, 2, and 3 in them. And then we're going to call the next, as soon as we do this, it'll call our subroutine using a call by reference. And you can see that those values, where it got multiplied by our negative number like we wanted, we now have in array elements 1, 2, and 3. If we go look at the code, you'll see that we now have negative 11, negative 22, negative 33. So you can see that we've in fact manipulated these values. And then if we proceed and come back into the main body after our subroutine call, you're going to find that those values were changed in the subroutine, because what we did is we handed it a pointer to our main array, and it said, okay, you want to manipulate these offsets, I'm going to do that for you. So the values are in fact manipulated when we go back. This is pretty typical. This is usually the behavior you want when you're doing something like this, but not always. So the other thing we can do is a call by value. Okay, and if we open that, I've got the exact same program, except we're going to do a call by value. And the only difference, if we were to look at the code, the only difference, it says instead of reference, it says value here, and instead of in out, it just says in for local array. Other than that, it is identical to what we have here. Okay, so when we do this, we're going to see a different operation actually. So it's kind of interesting. Okay, ready to go. Same exact code. The only difference in these two pieces of code is one says in out and one says in. So that's what we're going to look at. Okay, once again, we've initialized our main array to 1, 2, and 3. This is what we would expect. And now we're going to go into the subroutine, and we're going to multiply. So we got the same values inside the subroutine on our local array when we're in there. And now when we come back out of the subroutine and back into the main body of the program, we're going to see what values we've got back in the main body. And you can see that these bodies, that when we get back in the main body, these values were not changed. So when we manipulate it with a call by value using an in our argument list, it's going to take those values, it's going to copy them into another variable, manipulate those variables any way we want, could be destructive or not. And then when you come back out of the subroutine, the item that you called it with is unchanged. Okay? So that's the in, out. Tells you whether or not you can allow a change to happen. Well, why do we care? Well, for one thing, we care because if we want to destroy the values in something or manipulate them in a way that we, find a reason to, maybe we're doing some sort of min-max or something like that through a set of objects, and we're going to just stick whatever the max we find every time or the min we find every time back in the array wherever it is, we can do that locally, and we could pass back just a value out of this, out of the subroutine, and then we would not have actually altered the array that we had passed in. Okay, so that gives us an ability to preserve the item that we hand off into that array and when we manipulate it. However, there's a cost associated with that. And the cost is when we use n as a parameter, you're going to find that it takes up a significant amount more space in memory, because it's actually allocating these variables locally, and it takes up that space. So our code size, if we look at this again, this code is identical except for the word in, out, and in. There is no difference between these two items, and the fact that one says call by reference and call by value in the strings. So we have a byte or two off by the difference between the word value and reference. Other than that, the same size. So if we were to look at a call by reference, which would be the default, we'll go back to the first one. Okay, in our subroutine, if we look at the size of this code, 3,449 bytes, again, I assume that seems to be the thing. So this is how much space that's going to take up in the control processor when we compile this and install it in the CP to run. So that's the amount of space we're using. So not insignificant, but not huge. The same code done with a call by value takes 4,641 because it's having to allocate 300 in this case, because that's how big I set it up to be. It's allocating 300 reals that it's going to make for that array. So go ahead.
This is Neil. Question. You mentioned right at the beginning that the max allocation size was 3,200 bytes for HLBL. These numbers are larger, but is that because it's the space for the block as well as HLBL?
Well, I could be wrong on that, Neil. It's entirely possible. I was hoping there would be some people. The part I'm good at, or at least I think I'm good at, I understand what I'm doing and the size, and I understand ways to minimize the size. The part that even after reading through the documentation, and they explain that you can set the C space for code space, and you can set the values for that. But what I don't really understand is when you change a piece of sequence code and recompile it, okay, if that code size exceeds the previous size, I don't really know how the fragmentation occurs. I don't know how memory, and that was a question that I had for kind of the group is, you know, if we come through here and look, you know, obviously when you go through a piece of a controller, right, you've got your, in some way it's going to run through it at least this way. It does the ECB blocks, and then it comes down and does your continuous control, and then it'll run through your sequence code, and then it'll do the second piece of continuous control, and then they have data after that. So, you know, those are just holding basically, memory that's held, and you can stick stuff in it. And that part I've got a pretty good grip on. But I'm not sure what it's really doing out here as far as memory goes in the CP. So I don't really know. They tell you that if you know that you're going to be doing a lot of modifications to a piece of sequence code in the documents, and I can find that you should allocate a C space that's either 15% bigger than what it comes back with for the size, or you should allocate the max if you know it's going to be changing a lot. Okay, and I'm good with that, but I don't really know what harm it does if we just allocate the maximum size. I don't know how many sequence blocks I can fit in there, and I don't really know what, you know, obviously every time we recompile sequence code and change it, we're not fragmenting the memory space. If we were, we'd run out, everybody would run out. But I have been to plants that have run out of sequence memory space. So I'm not sure what the underlying mechanism is, and that's kind of, this is just a guess that when you make it allocates a certain amount of memory, and then once you exceed that, it says, well, I can't fit this block in there anymore, I'll put it somewhere else. And then there's a piece of memory in there that's fragmented. You reboot the CP, and it goes back and reclaims that memory. So you could basically clear up and fit more sequence code in just by rebooting a CP than you can if you're in one working on it. And I am open to the floor for people that have a better understanding of that than I do.
Okay, thank you. So I guess you're thinking, it's kind of, I realize you're saying you're not exactly sure, but maybe even though the max appears to be 3,200 because of fragmenting or something, it still kind of puts in a bigger number, even though it may not really be using it, but it's trying to take into account fragmenting, I guess.
Well, somehow it doesn't. I mean, the thing that we do know is that, every time we go through and edit a piece of sequence code, there must be some value there, because it's not just, we can work on these all the time or do a lot of them and do a lot of changes, and we're not fragmenting, we're not having people run into this problem on a regular basis, right? Everybody, right. I mean, so obviously it's not just sitting there and going chewing up the memory at a rate that everybody's like, oh my God, don't ever change sequence code. So either there's enough memory there that it's not a huge concern, and in which case I don't know why they've got all of these notes about it, or they're managing it to some degree, and then if you exceed that, it says I can't put it back where it used to be. I got to put it in a new spot, and then the old spot where it was becomes basically unusable pieces of memory, and that seems to be what fragments it. That's what I take away from reading the documents, but I don't know if that's an accurate understanding of it.
Okay, thank you.
So again, I am open to learning. I'm hoping that, on these things, that I'm not the only one that has experienced this stuff. So I'm looking over here at another document for that right now. See, and this is where they talk about it. I'm going to bring up the document here. And I'm in B0193 AWT, but it also has this in some of the release notes and similar things. And says, if the sequence code remains small enough so that it stays in its code space for its entire lifetime, this problem will not occur. Okay, and that's, we're talking here about fragmenting the memory. Okay, I don't know exactly how it determines if it can stay in its own code space or not, because obviously, like I said, most of the time when you modify sequence code, you're adding something to it, and we're not just chewing through these on a regular basis. So I'm not sure. But then it says, does support pre-allocation of memory for using the CSpace option, and you can set that, and then they talk about their simple set of rules, and they say if no changes are going to be made and doesn't contain subroutines that are going to be modified, then minimal change, average change, and maximum change. And then they decide based on that how to set the CSpace. If you're never going to change it, set it to 0. Minimal changes, set it to the size it is plus 15%, and then average 25, and then maximum you allocate the 32. Oh, it's 32,000. So I got a typo in my thing over there. So we will fix that and save it. So that's the maximum size that they allow for it. So that's kind of, then you get into SPX programming. So this is kind of what they tell you about it, but they don't really tell you much more than that. However, we do know that you can actually run out of just size on the CP itself and on a piece of sequence code. And one of the things that we've done is if you're using a lot of string variables and you're using the in parameter instead of in out, when especially there's no real harm to passing a value and using in out if you don't change it or modify it in the subroutine. Okay, so if you pass this as an in out and you did not modify it, just use those values, then that would be fine. If you meant to modify it, obviously you would use in out, but you could pass all of these with nothing there, and you save a lot of space in the processor memory. So that's a
sorry to interrupt, but one quick question: is in and out behave the same with internal and external reference?
With internal and external references, that's a great question, and I don't know. So you're saying if I were to pass like a Boolean N0001 or something that's referencing that to an array,
I mean in other block, so the same effect will be the same if you are passing parameters not within this block itself, maybe within other block.
I would say that if you're passing, what you're talking about is like anything that would be one of these, right? A user label type item?
Yes, no, not a user label of the same block, but maybe a user label of external block or other sequence block.
An unsecured external connection? Can somebody clarify that for me? I'm a little confused on what you're talking about.
David, perhaps the question is about whether in some programming languages we can open a file for reading and writing, which would be an external source, as opposed to defining the array inside this code.
Right, but I don't think we have a way to do that with sequence code, do we?
That's what I was thinking too. I don't know if we can open a file for reading and writing, so I don't know if there is a way to get external code into an array, except the hard way.
Right, and the other thing is if we're talking about the items that are up in here that are user labels and things like that, these are basically global. These are just declared as global variables, internally. These user labels, if you put a user label on this, it's good wherever. And I'm not sure what would happen if we pass that with the in parameter to a subroutine, if it would make a local copy of it, and then if you changed it, it wouldn't write it out. I don't know what would happen. We would have to try that, and I could do that.
Yeah, maybe I put it in other form. What I mean, if can we pass into our subroutines, let's say a hash define parameters, so that's pointing to other compound block parameters, maybe a gdiff parameters into my subroutines. Okay, so if I'm using that and passing this argument into my subroutines, what is in and out will do in that case. You get my point?
Okay. So if you pass you'd have to put them in a string parameter. You can't just pass them, willy-nilly. Yeah. But if you were to pass it as an argument, right? If you pass the compound block parameter in a string, the same rules would apply. You could modify that string if it was in out in the block, or you could just use it and not modify it, or you could pass it with the in parameter, and then it would be impossible to modify it back in the main routine, because what it's doing when you pass it like that, and this is another thing that I did on purpose on this, is that here you see in the subroutine I made a variable called index for my loop array. which is just an integer variable, very standard thing to do to loop through an array. And I've got the same variable declared globally up here in my variables. This was an attempt to see if I could in fact declare a local variable with the same name, and you can. So it does truly treat, if you go into a subroutine, if you want to have local variables, and for things like a loop index, that's a useful thing to do, right? Even because you just say, well, all I'm doing is looping through this. I just need something close that I can hold. And when this subroutine exits, you know, if this is done like I would expect it to be, these local variables, you know, are basically created and destroyed when the subroutine is called, when they're created, when it's called, and destroyed on exit on the local stuff. And so, you know, you come back here, you're still using whatever you had in your index from the main thing. These are two different things. So you don't want to, what I would advise against is naming variables the same thing in a subroutine and globally, unless it's something that you can see, you know, very tight scoping basically, and say, okay, if I name something down here, it's only going to apply in this subroutine, like index. And if I have a global block with a similar or the same name, I'm not going to get confused. But you don't want to pass in an index just to use a variable inside a subroutine. That's not a very effective way of doing this. Another thing that it would be ill-advised is setting globals inside a subroutine without passing them in so that you see that you're intending to do something with them. In other words, that's a way of really tripping yourself up later, is having, you know, because a subroutine can set global variables, but it's very difficult if you're passing in arguments and also setting global variables to keep that straight. And I would recommend anytime you're working in a subroutine, you pass in anything that's, you know, going to be manipulated from the calling area of code. You don't want things in there that are being manipulated, that are kind of side effects of a subroutine that you don't see passed back and forth through the argument list. So hopefully that makes sense. And I think those are pretty good guidelines. I don't think there's any reason that you would want to ever not do that. So, you know, the difference is that we found where we were passing an array with a lot of string values, and we had several fairly large, which we were manipulating external compound block parameter, you know, unsecured references, and we were constructing them out of this array, that one of our younger guys passed that in with an in parameter. He said, well, I don't ever want to change these in this array. And I said, well, I understand that. So he passed it with an in. Well, of course, now it allocates the entire string array size for that subroutine. And he actually got to the point, it's the sequence code said, I can't compile because I don't have enough code space. Well, it's okay to pass them as an in out or a call by reference if you know that you're not going to manipulate them anyway, right? All I'm going to do is read these values and use them. And so that gave us the ability to fit a lot more into the same, the code was functionally identical, but the size was, you know, significantly smaller when we made those in, the functions that were being called with an in became in out or nothing, because that defaults to in out. So you just take that off and suddenly you're able to work with a lot more space. So let me see where we can go from here. Right, so we'll go here. Right, okay, I modified that. So we know that recompiling sequence code is going to cause that, and we don't have a whole lot beyond that we can talk about. We don't really know. I don't know what it really looks like. I was kind of constructing that, and I was hoping that we would come up with, that somebody on this call has seen this and says, "Oh yeah, well, when you do this, this is what's happening." I'm also curious as to what that looks like when we go to the CP and it allocates for sequence in the station block. Maybe it'll show us. We get a loading summary, and see here we have that's the largest segment of memory that's free, and that's our total memory that's free. So if we recompile, if we were to set that array to be significantly larger, I don't know what would happen, to this total free station memory, if this is where it gets absorbed or not. That would be another thing that would be probably a good experiment to try, and we could do that pretty quickly.
David?
Yes.
I may have some experience with this. I was an older CP3, so the numbers were a lot smaller. CP30, I mean. But
Right.
I had a sequence block that had grown over time, and I eventually grew outside of its original boundaries. And I don't think that it's fragments the code. When the code no longer fit back into its original space, it tried to move it to another space that was big enough. And what led me to this conclusion was my total free space was big enough to contain my sequence code, but my largest segment was not big enough. So when it outgrew its original assigned memory space in there, it tried to move it to another one, and I had none big enough, so I had to change that code back or just cancel the modifications I made. But that's a conclusion I came to based on, like the little bit of information that we get.
Right. And that might be, like I said, I mean, the nice part of doing this like we are, right? If we come in here and we just bring this up and we say, okay, call by value, this is the one that's going to make it, significantly larger if we edit it. So let's edit the sequence code. And we'll put,
Yeah,
Yeah.
I think also one more practice that we used to do is in engineering phase or at running sites is to make use of available window for shutdown, because I think rebooting your CP will make these defragmentations, and it will be good enough, to allocate the sequence code in one memory slot. So I think rebooting, if is an option, is a good practice to solve some of these issues.
Oh yeah, and I agree with that. I mean, that's another thing. If you can do this on a development system and go through these operations until you get it like you want, and then put it in, that minimizes the amount of code that you're going to have do the fragmentation. And then after you've got a plant up and running and it's been running for a while and you've got all of your code in, if you get an opportunity, during a normal part of process operations to reboot, it does help with that. It does free up the, that area. So let's see, we went to 3,000 of these on this. And we had 4088 and 64. So, okay, it just is taking it out of the total free. And we didn't exceed, I guess, our largest segment size, or we didn't get out there in that. So that is still the largest segment that's available, but it just took it out of the station free memory when we did that. And that's and I think that it allocates that for the subroutine when you compile it and install it, and it's not dynamically taking that memory and then, you know, freeing it up and taking it back when it's running. I believe these things are basically, it determines, you know, how it's going to do that, and you're there. And I don't think you can do a recursive call on subroutines or anything in sequence code, so it would know that at most it's going to have one instance of the that subroutine at any given time, so it can allocate that memory and take care of it. So that is, for the most part, what I was going to talk about today. We got plenty of time left. If anybody has any other topics related to this, or any questions or comments, I would be willing to entertain them, or things that they would like to see us go in a future thing. You know, I'm open to suggestions. Clearly, everybody has a lot of great ideas. This is, I have a question. This is, and I saw it pop up and it went away.
This is Ismail.
Yes.
Not sure if you can hear me. Yeah.
I can.
One of my peeves is having only the memory in the detail display to work with. So if I am working with arrays, I have to map everything into the detail display, or have maybe some slave blocks to see what's in those registers. And I was curious if there's any way to use debugger or some sort of a dump to see what's in memory. If that makes any sense.
It does. Yes, and I understand that question, and I don't know of any way to do that short of writing. You know, like you just said, you either write it out somewhere else to an exposed, value, variable or whatever, or you put a bunch of diagnostic statements in there, or you're kind of limited to what you can see in select, like you said, as far as where your code is and what it's doing and how much memory is being used and what the values are. So I'm not aware of any debugger that lets you look at what's in memory on the stack, things like that. Anybody else got anything? I mean, as far as being able to look at this stuff? Because I think it's an interesting question.
I think here you are talking about variable, not a global variables, right? So for global variables like user labels, it's obvious from the screen itself, but for the variable is most challenging part. No, I don't think there are any way, but in some project we used a technique to debug the local variables. So what we used to do is we have a data block that's called debugger or something, and at initializing of the codes, we read all the local variables into that debugger. So one statement, list of statements that just read each and individual's variables into this data block. And when it's time, we can pause the sequence and we know which step we are, and point to the statements where we load the local variable into this data block and return back. And then at that time only we go back to the debugger data block and we can read the value. But this is just a technique, it's not, come out of box or something.
Right. So basically, you're effectively, although you may have had a better way to do it, to put it into the data block, but you're basically using debugging statements. You're saying, okay, copy these values to somewhere I can see them, and then, okay, I'm on this step. Well, now, okay, do the next step. Now go back and look at those values that I've copied to somewhere I could see them, and you know what's changed, as opposed to just being able to say, okay, I'm on this step. Go look at the memory. Take a next step, go look at that same set of memory, and then you can see what's changed. We don't have an easy way to do that. So I've not found any way to do that. You know, so that might be, you know, that's pretty advanced though, I think, Ishmael, if we're doing things that are requiring that level of, you know, debugging. I think some of the more complex stuff we've done in sequence code is things that probably are either heavy array manipulation when we're trying to do some math functions, or some string manipulation, and that tends to be where we make mistakes and wish we could go back and look in like a debugger or something. But most of the time I can copy this into some sort of variable, expose it, and then, you know, it's a hassle, right? Because it takes a lot of time to go back in and write these debugging statements and then take them back out when you're done, because you don't want them in there, you know, for the execution speed and everything. So I understand the desire to have it, but I think it's usually, sequence code is simple enough that we can work around it. But it would be nice to have something like that. You know.
I have one question. In your sequence, you have been using the arrays. Are there any ways to expose these arrays into graphics or other sequence to read or consume the array data straight away from graphics or other sequence?
There are a couple of arrays that are exposed just because of they're basically user labels, right? We have real array, I think, and then there's this, you know, integer array and Boolean array. These 1 through 4, 1 through what looks like 1 and 2 for real arrays, and I don't even know. I'd have to look and see what the maximum number of elements in those are, because I'm sure they have something that's not, you know, probably too big. But those you can look at. They're outside. Using the object manager, you can connect stuff to them and get that value. But
So what form of graph, if let's say I want to consume the real array, you know, the first real array, the first vector or whatever. So what compound block parameters that I'm going to use in my graphics or get, or, you know, calling in other sequence?
That's an excellent question. I don't know off the top of my head how you can. I know that we have done something with that as far as passing them around between sequence, but I'm not sure how you would expose that on a graphic or anything. Let's take a look. Let's see if we can figure out one real quick. Let's see. I think it's what
So what I think is it is, you know, like masking or ORing the entire array. when you call that, but are there any way to look into specific?
I do not know the answer to that. To go after an actual array element and put it on a display or something.
Yeah, that's what I've done in the past. That's what I was getting at, because I've done things like averages, moving averages, and whatnot, and I just put it into an array, the samples, and then in order to make sure that I'm populating the array correctly and iterating through correctly, I just have to create a bunch of slave IND blocks just as memory buckets, and so I can watch them and or put them on the screen.
Right. Yeah, that would require a little bit of work, obviously. If it's just that array is out there as a piece of memory, then you might be able to, you'd have to almost write a piece of custom code that would do an object. You would go get that object out of the object manager and parse it for you. I don't have anything like that immediately available. So that's a good question, and one that I will look into as far as the ability to access array elements on these. Is there anything, I mean, as we go forward, or should we go forward, is there any more topics that people want to see discussed or looked at on the sequence code, or do we feel like we've kind of exhausted this topic? And I've had people asking questions like we should do stuff on some other blocks or some simple control strategies or things like that, which is fine. I have no problem with that, but I'm just wondering, this is an area that I have a lot of interest in. I'm trying to improve our ability to write sequence code. I've been working on this now for, I don't know, a long time, but certainly we're trying to get this information out and trying to get other people to take advantage of what we can do with it.
Well, two
Hey,
things.
David?
Go ahead.
Go ahead.
Two things.
This is Neil.
Okay, I'll pick Neil first, and then I guess is Ishmael second.
Okay. David, one topic that I don't think you've gone over yet that might be of interest is some of the, I guess you call them like preprocessor commands, things that you put in the code that basically allows you to exclude or include additional codes or based on compile. It's a really advantage when you're using a common source code that you're going to compile, like say for a bunch of several different equipment where there's a lot of similarities, but there are some differences, and depending on, let's say it's a batch kettle, and if you're doing it for these kettles and compiling, it'll put these bits of code in there, and if it's this other one, it'll put this different. So anyway, that kind of subject might be of interest to some.
Okay, I would be willing to do that on the preprocessors and the if-defs and stuff like that before the pound defines. Yeah, that would be actually something we could certainly spend a little time on. Ishmael, did you have something?
Two things. One is I believe there's a canned sequence type function inside the IND block. Typically, I make my own sequencer just because I'm too lazy to read through the details of how there's any particular vendor's canned sequencer works. So that's one possible area. The other one is exception handling. For whatever reason, our guys have not implemented historically any exception handling in IND blocks, and it's caused problems where a particular momentary glitch caused an error in the IND block in a non-critical function,
Right.
and it's instead of continuing, the block failed,
Right.
and so from that point on, it was failed until somebody noticed that it had failed. Whereas if it had one particular glitch, there could have been a fault handler to basically log that glitch or do something and continue. So
Yeah.
those are two areas that I'm interested more so in fault handling than in their canned sequence.
Well, that's actually that is a good topic, and one that I think we can speak to is the exception handling. And I think we could write and test a bunch of exceptions without a great deal of effort and say this is what they do, and these would be some best practices. And we have some of those. Obviously the exception handling typically, again, the stuff we're afraid of, the things that I'm afraid of when we do this is anytime we have an unsecured connection, we have potential to have an exception that becomes a problem, especially unsecured writes more so than unsecured reads. Those become something that you have to be on the lookout for. And the other thing is, and obviously in this code we weren't doing it, but anytime we're doing division, right, and you start getting numbers that are approach zero, somewhere you could divide by zero or throw a math error, those are exceptions that can be handled with an exception handler. And it's probably a good idea for us to look at that. So I believe exception handling would make a good topic for one of these.
I like the idea of the libraries and the preprocessor definitions as well. That's pretty handy.
Right, and we could do that as well. In fact, the two of those, if I spend a little more time, this month I've been busy. I was planning to do this on Tuesday and was at a customer site, so I had to reschedule. So I haven't had as much time to devote to this. Although I do think that the memory management part of this and the knowing the difference and being able to look at these subroutine calls and say is this something that I care about? And we do want to minimize the amount of memory that you're using. And if you're going to be, like I said, making a call where you've got it as you're not going to modify something, it's okay to hand that off by reference and not modify anything in it. It actually is faster, and it takes up less memory to do that. So it's something to think about. Putting that in parameter out there obviously says this will not change, and it won't when I come back into the calling section of code. But not having it doesn't mean that you're going to change it. It just means I'm going to pass this in, and it could be changed inside that subroutine. So if you don't have to explicitly say that, it's not a bad idea. That's to defend today's topic. But yeah, the exception handling and how you construct that would be good.
Yeah, I have maybe one more topic to add, and I think one of the great use of the sequence block is the batch applications. So how our sequences, independent and dependent monitor exceptions is handled through the ISA 88 and the IA batch. What is the kind of the best practice modeling we can utilize our sequence block, different type into the batch control.
Right. Now, and we could do that. We've done IA batch or in batch now quite a bit with that. One of the things that, when you go through the batch system, the in batch, and look at how they do that, Foxborough has a fairly well-defined way that they want to go in and exit from a phase, like phase logic or something like that.
and that's worth looking at. That's certainly something that could be discussed, because it's not a, once you understand it, it's pretty straightforward, but it's not very clear. The first time you see it, you say, why would anybody do this? And then after you look at all the other things that happen, you say, okay, there was a good reason for the way they did it. But basically, a Foxborough sequence block that's going through in batch is going to exit with an abort exception every time. Is the way they get out and clean up on the way out. But they do that in a clean manner. It's not just some, and like I said, once you see what they're doing, it's like, oh, okay, I see why they did that. But it's not something you would typically do on your own. So, okay, that gives us a few other good topics that would be worth exploring. I think we can do that. And, I am certainly open to emails, and, if anybody has anything and they, didn't want to bring it up in front of everybody or anything, feel free to email me there. I am, David Johnson at premier-system.com, and I would be happy to try to do this and make this as good as we can, and hopefully people are getting some value out of this, and we'll keep doing it as long as people say it's worth doing. And with that, I've wasted almost another hour of your life, and I appreciate it, and I will let everybody go back to whatever they're doing during this quarantine time, and hopefully everybody is getting back to work.
Thank you, Dave. Very good.
Thank you, David.
All right, you're welcome. Thank you guys for attending.
Thank you, David.
Thank you.